Now let's take a look about the second example which you meet frequently in your daily life. Did you notice that when you are driving during a rainy day, it is much harder for you to see the road conditions? People may argue that it is because the sun was blocked by the cloud. The answer is yes, but this is not the main reason. The reason you cannot see the roads clearly is due to these transparent and opaque materials. So during the on the day with no rain, the surface is dry. When the light interact and exit on the surface, they will simply just bounce back to your eyes directly. However, when it is raining, the road is wet, so now the bouncing happens about a transparent wet regions, and they will absorbing the energy away from every bounce. Even eventually, the light is still reflected back to your eyes, but now the energy was consumed. So therefore, when energy decreases, do you remember the frequency becomes smaller? So therefore, it will affect the wavelengths you see. And that is the reason why your eyes will receive a darker, which is a lower frequency wavelength, because the energy was consumed during the bounce of the water molecules. Now let's take a look about how does the speed of light depend on the material, the medium. So let me emphasize one thing in case people have a confusion. So the speed of light is a constant. It is 3 times 10 to the power of 8. This value, no matter where you are, as long as it is in the vacuum, no matter what kind of frequency, this is the same. But if the light is propagating in the atmosphere, in the air, then the speed of light is still a constant, but this constant is no longer the same value. The reason is because you can try to think about that in the vacuum there's nothing there, but from nothing entering to the regions with some particles. The propagation of the light actually involving with the bouncing back and forth about the air molecules. Agree? So therefore, if you involving with extra time of the bouncing back of the electron within the molecules, you have to spend more time doing that. So therefore, the speed of light will be slowed down. So apparently now the more molecules you have in that medium, the slower the speed of light it will be. It is due to this kind of interaction of the photon and electrons. So you can see that diamond is a very dense object. So the speed of light in the medium of the diamond is only 0.41 C. But still, no matter what kind of wavelengths or the frequency of the EM wave, when they propagate in the diamond, the speed of light is still the same. So they are totally different concepts. Now I'm going to introduce you the mirror. Why the mirror is so important? We use them to show us the image. Yeah? So back to the history, the first time we can record it is people started to use the mirror is back to the 6000 BC. People use the obsidian. This is kind of material produced near the volcano. People find out they can reflect the image. And people later on find out the bronze, silver, and copper can also be used. Did you see that depending on the material used, it means that this is how the civilization grows. So people find out a better and better material to reflect the image. So apparently here they reflect the image, but it is definitely not perfectly. They don't show you the true image. So the one which is widely used now, use the glass as a mirror. This was discovered in the 17th centuries. So just about 500 years ago. Then people find out, okay, glass actually is a very good material to reflect the mirrors. And you will find out that when the civilization progresses, people have a method to control and match the material we want. But before I show you how does the mirror can help us to form the image, we have to refresh our memory about the concept of the law of the reflections. We know that the light, when they interact with the surface, as the surface is not transparent, which means the light cannot penetrate through. and mirror is a very good example of that the light will be reflected. And the law of the reflection tells you that the angle of the incidence is equivalent to the angle of the reflections. So how do we define that? I know I already mentioned twice already. This is the third time, but this is so important. So the angle is determined based on, you have to draw a virtual normal line. This dashed line here, it is always perpendicular to the surface of interactions. So the incident angle is this one compared with the normal line, and the reflection angle is the angle compared with the normal line also. And these two angles should be the same. So we already studied this one in the chapter 10. But now in the chapter 11, we are going to use that particularly for the EM wave, which is a light, the reflection of light. So now, if you put an object in front of a mirror, let's consider this is a perfect mirror. Definitely, they will form the image. How does the image was formed? So, did you see some ray I just draw here? So, all the rays follow the so-called law of the reflections. So, there are 3 rays I just produced. So, here, this is the first one. They hit the top of the mirrors, and it is reflected. Agree? And you have to draw the normal line so you can find out the direction of the reflected light. So the way how the image was formed is that you will find out this is the direction of the reflected light. But if you trace the direction backward, you will see that they will come to this point. Now let's draw the second light and ray. You will see why I'm going to draw the dashed line. So the second one, they hit in the middle of the mirror, and it is reflected in these directions. And now you trace the reflected light backward, follow the dashed line. You will find out now the 2 dashed lines intersect at the same point. If you don't buy this argument, you can try to draw the third one. You will find out the third one, when you draw the dashed line backward, they all meet at the same point. And this point is where the image was formed. Okay? That is how you find out the position or the location of the image. And you will find out, I will say this image is virtual. When I say virtual, it means that it is an image formed by the virtual light. Okay? The dashed line are not the real light. Okay? They are the virtual one. So therefore, your image is virtual. But your eyes will give you an impression or illusion. Say, okay, now this is image of that. And the most important facts about the mirror image is that the size you form will be the same size of the object. And that's the reason people find out the glass is a very good one. If you use the bronze or copper, they cannot produce the same size of the object. So the size of the object is equivalent to the size of image. The second thing is that the distance from the object to the mirror. The distance from the object to the mirror is the same distance from the mirror to the image. So these 2 distances are the same. And this is only for the plane mirror. Okay? That is very important. So therefore, now you will say, when you go out and say, I want to purchase a mirror, and how long the mirror should be, then you should consider that. Ideally, you don't need a mirror show with the same length of your height. Actually, based on the law of the reflection I just showed you, you will find out you only need half of the length. The length of the mirror is only half of your height. So if you are 200 meters tall, then you only have to find out the 100 meter length of the mirror. Then you can form an image with the same size of yours. So you can see the complete the image of yourself. So this is mostly due to the law of the reflections. So you can see that now the light from your eyes was reflected. So now the image of the top should be received here, and the image of the foot should be received also here. So you can see that actually this triangle and this triangle are similar. So that's the reason why that the length of the mirror is just half of your height. Now let's take a look about the conceptual quiz. So now you stand 2 meters in front of plane mirror. Then the image will be, the answer is C. So the image is still 2 meters from the mirror, but if it is from you, then it is 4 meters. Now let's try to refresh the thing we have also learned in the chapter 10, the refractions. So light is a wave, so they also have the refractions. So I mentioned that when the wave propagates from one medium to the other medium, the light will be bended. Now I propose that another explanation for that. Consider you are biking with the tires here. So originally they are all rotating within the, for example, in the air. Now, when you try to enter in from the area into the glass regions, so you will see that this tire will enter in the glass first, or the grass first. So apparently the friction between the normal floor and the grass will not be the same. And you can tell that actually the friction will be less. So what happens is that because the friction becomes less in the grass, then the speed of the rotation of the left tires, they will rotate less efficiently. So which means the speed of the rotation, it will become smaller. But the right tire will still rotate at the original speed. So this will happen as scenario is that now the two tires is rotating at a different speed. And this is actually the situation happen also when you are pressing the brake. So now what happens is that because the different velocity of the rotation of the tires, now you can see the car will be bended. And because the rotation of the speed, now you can consider it is the speed of light in the grass or in different material is slower. So when you entering from a region with a faster speed of light to a region with a slower of speed of light, then the light will be bended toward to the normal line. So this is so important. Now I teach you how to determine the direction of the light is bended. So from the media with a higher speed of light to a lower speed of light regions, the light will be bended toward to the normal line. So that's the reason you see from the air to the water, once again, the speed of light is faster in the air, and slower in the water. So the light is bended toward to the normal line. This principle is the same for all of them. However, if you try to reverse the directions, how about the light entering the air from the water? Now you are entering a region with a faster speed of light. So consider the arrow is in the reverse directions. So you can see that if the light is traveling in these directions, entering into the air, now the air has a faster speed of light. So you can see that it is bended away from the normal line. Away from the normal line. This is very important. Super important. So you have to know why. And this one, the reflection of light, explains that why the image you see when you put a fork in a bottle of glass with water, the image is bended. You can see that now this is the fork in the air and this is the fork in the water image. You can see that they are completely bended. It is not a straight one. But you know this is not true. And the reason is because the refractions, the image from the light will be refracted. So that's the reason they create an illusion, show you that, okay, now it seems this is the true position of the fork, but intrinsic it should still be here. So now let's take a final conceptual quiz today. So if it is bended toward to the normal line, it means it slows down. So it depends on speed of light, and that is very important. So we will continue our discussion after the Good Fridays. So I hope that everyone will enjoy your good weekend, and also I will try to post your grade of the previous labs and the midterms on the Moodles. So please give a check during the weekend. Bye.